In this lesson, we shall solve questions on analytical geometry. We start by focusing on question 3. In the diagram below, points P with coordinates 5 and 13, Q with coordinates -1 and 5, and we can see that here, and S with coordinates 7, 5, a decimal comma, and 8, and obviously we can see that on the diagram here are given. SR is parallel to PQ, and we can see clearly that we have that SR is parallel to PQ, where R is the y-intercept of SR. Okay, so we are able to see clearly that R is there, and is the y-intercept of SR. Okay, now the x-intercept of SR is B. Okay, you can see B there, and QR is joined. Okay, so we have that QR is joined. Calculate the length of PQ. Right, we're interested in finding the length of PQ, and we can see P is clearly there and Q is there. We want to find the length of PQ. Okay, now there's certain things we need to take note of here is that this is x1, y1, that is x2, y2. If the examiner describes as PQ, the examiner obviously is taking into account the movement from the point P to the point Q there along the line. Okay, so now to find the length, we use, because the question is asking for the length, to find the length, we use the distance formula. So we have x2 minus x1, which we square, and we add to y2 minus y1, which we square, and we actually then put everything under the square root sign, like so. And we then have that PQ itself is given by the following. Right, is given by the following. So what is x2? Right, x2 is a -1. What is x1? It is clearly a 5. We square that. What is y2? It's a 5. Y1 is 13. We square this, like so. Okay. What then is the meaning of all this here? Right, so if you have -1 minus 5, what do we get? We get actually a 6. And upon squaring, we get actually a 36. 5 minus 13 gives us a -8, which we square, and that gives us a 64. 64 plus 36 together give us 100. And the square root of 100 is 10. And we're calculating length, which is measured in units. And therefore, I mean, what we're able to see here is that PQ itself is 10 units. PQ is 10 units. Right, so we have found the length of PQ, and it is exactly 10 units. And we look at the next question. We want to calculate the gradient of PQ. What is the gradient formula, Tando? Do you remember the gradient formula? If we want to find the gradient of PQ, so moving from P to Q, P will therefore have x1, y1, and Q, so that we do not forget, we just put these labels here on the coordinates. So that now we want to find the gradient of PQ, and therefore we have gradient of PQ. What is the gradient formula, Endo? It is y2 minus y1 over x2 x1. And what is y2? It's a 5. Y1 is 13. We divide by x2 is what? Is -1. X1 is a 5. What is 5 minus 13? It's actually -8, and you divide by -6. Okay, and upon careful examination, we're able to see clearly that this is 4 out of 3. If you divide, the negative cancels out, and you divide by 2 here, getting a 4. Dividing 8 by 2, you get a 4. Dividing 6 by 2, you get a 3, so that we have 4/3. And we're able to see, therefore, that the gradient of PQ here is actually 4/3. And the gradient is dimensionless. It is without units, and it is only a number. And we've written the number there. Okay, right. So we found the gradient of PQ as required there. Next question. What to determine the equation of line RS in the form AX plus BY plus C equals 0? And we focus on the next question. Right, 3.3. To determine the equation of line RS. Right, so now the line RS, we want to find the equation of the line RS. How, therefore, can we be able to find the equation of the line RS? Now, because to find the equation of a line in this form, we actually need to recognize that we need the gradient of the line. But this line here has the point R as one of the points, but the coordinates of R are actually unknown, and therefore take note of the fact that the gradient we want, which is the gradient of RS, is actually equal to the gradient of PQ. And the gradient of PQ we've already seen is actually 4/3. It's actually 4/3. So that in the end, then what we have is that this is 4/3. Why is this 4/3? It is simply 4/3 because we are able to see that RS is actually parallel to PQ. RS is actually parallel to what? It's actually parallel to PQ, so that we have exactly the quality of the gradients of the parallel lines. So if two lines are parallel, if two or more lines are parallel, then their gradients are equal to each other. And therefore, we have that this particular line RS passes through the point S with the coordinates 7 decimal comma 5 semicolon 8, like so. To find the equation of a line, we're going to use the slope point form. Y minus y1 equals m into x minus x1, like so. Okay, now obviously we agree that it passes through this point here. This line RS passes through the point S, so that you have y minus y1 is actually 8 equals m, the gradient, which is 4/3, open bracket x minus x1, which is 7 decimal comma 5, like so. And then now let us continue to deal with these and see what we can achieve at this point. We want to multiply everything. And so to multiply out, we're able to see that y equals, so now this one is going to be exactly 4/3 x minus. Okay, then you have 4/3 multiplied by, now the 7,5 is the same as 15/2. It's the same as 15/2, and then we add 8 to everything. We add 8 to everything, so that y is 4/3 x minus, okay. Now here we can divide 2 cosine times. Now 3 divides, let's just do some simplifications here. So 3 divides 15, giving us a 5. 2 divides 4, giving us a 2. And therefore we can see, therefore here we have a minus 10 plus 8. Right, and upon careful examination, we're able to see, therefore, that y is 4/3 x minus 2. And this is actually the equation of the line, but it's is to be written in a more compact form, and not just this. So we're going to actually proceed to simplify this here. And to simplify this, so this implies, therefore, that we have exactly a 3y. Right, so if you multiply everything, we have 3y. And, or we need to write, okay, let's just write like that. Right, so we have a 3y. Let's write a little bit up here. Here we can push it up a little bit. So, yeah, at this point, this implies that Multiplying through by 3, the denominator, with 3y equals 4x minus 6. Okay, I want to write it this way. So we start with the x terms first, and we can write it as exactly 4x minus 3y. We keep the 4x on the right-hand side of the equation. We subtract 3y, and we have minus 6, and the result is 0. And this is the equation of the what? Is the equation of the line in the required form. So the answer to 3.3 is actually 4x minus 3y minus 6 equals 0. 4x minus 3y minus 6 equals 0. We continue right now to look at the next question, because this was 3.3 and we focus on 3.4 to see how to determine the x coordinate of B. Right, so we look at 3.4 next. Right, to look at the question 3.4, we need to remember the equation of the line RS. And we remember from the previous question that the equation of the line RS is as follows. So now we actually are able to recognize that we have the equation. Right, the equation of RS. What is the equation of RS? We saw that before. It's for x minus 3y. Minus 6 equals 0. We're interested in the x-intercept. So we let y be 0. So that if y is 0, we're for x minus 3 times 0 minus 6 equals 0. Right, obviously we have already got this equation of RS as 4x minus 3y minus 6 equals 0. This gives us 4x equals 6. Okay, transposing the 6 to the right-hand side of the equation. And we want to solve for x. And obviously we're interested in finding, because the point B itself is called the x-intercept of the straight line. So we're able to therefore find the x-intercept, and we divide by 4, both left and right, and getting x is equal to 3 out of 2. And we want to therefore determine the x coordinate of B, and therefore the x coordinate, not all, obviously x coordinate of the point B there, because the y coordinate, it's obviously 0. And we can therefore see and certainly say with confidence that the x coordinate of the point B is 3 over 2 there. Okay, how did we get the x coordinate of B? B is this one. To find the x coordinate of a line, you realize it is the x-intercept at this point here. It is the x-intercept of B. B itself is the x-intercept of the line that is running from R to S. And so we then say, to find the x-intercept, we say let y be 0. We always do this. And we, with no exception, obviously use the same modus operandi in this question, and we're able to get that x is 3 over 2. And obviously, I mean, this is the x-intercept, and we could certainly therefore say the coordinates of B are the x component is 3 out of 2, and the y component becomes 0 there. Becomes 0 there. Okay, so we have exactly these. And then we continue to solve the next problem, and the next problem is 3.5. In 3.5, the question is calculate the size of the angle ORB. Calculate the size of the angle ORB. Then you have the angle ORB. And we want to find the size of that angle. So how can we find the size of the angle ORB? We find it step by step as follows. We find it step by step as follows. Right, so to find the size of the angle ORB, we proceed as follows. We first have to find the angle alpha. And to find the size of the angle alpha is called the angle of inclination. Right, it's called the angle of inclination of the straight line. How do you find the angle of inclination? We use the tangent formula. Okay, so we already know that the equation of this line RS is actually 4x minus 3y minus 6 equals 0. So that in the end, then, you then say the tangent. The tangent of alpha is the size of the angle of inclination. And now we can just manipulate here and have 4x minus 6 equals 3y. You divide through by 3 so that we have 4 over 3x minus 2 equals y. Okay, now find the gradient, and therefore the gradient is 4/3. The gradient is 4/3. So that now in the end, then you have 4 over 3. And then if you look at the arctangent of 4 over 3, use a calculator, that is going to give us exactly the angle 53. If you do arctan of 4/3, it's going to give us 53,13 degrees. So that gives us the size of this angle alpha. And then now if we have the size of the angle alpha, the couple of things then that you need to take into account. So we actually can just enlarge this diagram a little bit and then say, if you have this line here like that, which is the line RS, and we want to find a couple more things here. This is RS, and we have this one that is running across like this, and this is the angle alpha, and we have this kind of a formation. Okay, this angle here is 90 degrees. As can be seen, the y and the x-axis are orthogonal vectors. They're orthogonal axes because the y-axis and the axis are perpendicular to each other. So, but now we are able to note that this angle here is equal to the angle alpha because we have vertically opposite angles. Right, and that means that we are in business because we have a triangle like this, a triangle like that, where this angle we already know is 53,13 degrees. Right, if this angle itself is 53,13 degrees, what then can we write that is much more? Let's write something a little bit bigger, a little bit bigger. This angle is 53,13 degrees. Okay, a decimal comma, then this one is actually 90 degrees. So I want to find the ORB, want to just find this angle here, it is the unknown angle. And therefore, we actually are able to make the following inferences. But first things first, we're able to see, therefore, that this is the angle OBR. So we then say that the angle OBR, all right, the angle OBR is also equal to 53,13 degrees. And why is this the case? We have vertically opposite angles. Vertically opposite angles, because these are angles in X. If you have this, then you remember vertically opposite angles are equal, so that these angles are equal and those are as well equal, so that in the end, then this is what you have. But now, what then more can we achieve out of this? We are able to realize that this angle equals this, vertically opposite angles, and we have a triangle like this. So how do we find if this one is O, and this one is the angle B, and this angle at the bottom is the angle R? How do we find the angle R? How do we do this? Now, to find the angle R, we actually proceed to use the sum of angles in a triangle, angles of a triangle. So we then say the angle ORB is 180 degrees minus. The angle ORB, this angle here is 180 degrees minus the other two, minus 90 plus 53 13 degrees. The angle ORB is 36,87 degrees. Yes. So, which is what the examiner wants? So they want ORB, and the angle ORB is actually that one. So it is actually exactly the same as 36,87 degrees, and we have found the angle ORB there by calculation. So take note of this and make sure you understand this very, very well. So we have answered this question 3.5, and we have determined the size of the angle ORB, which is 36,87 degrees. We want to prove that the QBSP is a parallelogram. Prove that QBSP is a parallelogram. Right, Q, okay, B, SP is a parallelogram. Right, and to prove this, so let's continue here and do this one. So to prove that QBSP, so here is Q, here is B, so you can join this like that. So the examiner is arguing that this is a parallelogram so that you have those sides parallel like that. How do we arrive at this? How do we arrive at these? How to prove that QBSP is a parallelogram? Right, to prove that it's a parallelogram, we need to prove that the opposite sides are equal, but also we need to establish that the opposite sides are parallel, the diagonals themselves bisect each other. Right, so let us achieve some of these things. Let's find first, in 3.6, the length of BS. The length of BS. We already know the coordinates of the point B. We found it previously. The coordinates of the point B are 3/2 and 0. 3/2 and 0. And we take these to the next question. The 3/2 and 0. 3/2 and 0. So that now BS itself is as follows. X2 minus x1 squared, y2 minus y1 squared. Right, so we get the following. So that now we have BS. So if you have BS, then we have x1, y1, and then we have x2, y2. And we have the following. So now to deal with the BS, we're going to therefore say x2, which is 7,5 minus x1, 3/2 squared. Y2 is 8. Y1 is 0. Okay. 3/2 is the same as 1,5. So we have 7,5 minus 1,5. So in 7,5 minus 1,5 is the same as what? It's the same as exactly a 6. Then you square that, and this is 8 squared. And 6 squared is a 36, and 8 squared is 64. And this is 100. And the square root of 100 is 10 units. Right. And so this is what we have. So that then in the end, we have found the length of BS. So that you have PQ. Okay. PQ is parallel to BS. And PQ is parallel to BS. And PQ is equal to BS. Because we found PQ, and PQ was obtained before, was found to be 10 units. That was PQ, but also now we have found BS, it is also 10. But moreover, we have been given that PQ is parallel to BS, and it is most certainly equal to BS. And that means that we can conclude, therefore, that therefore PQBS is a parallelogram. PQBS is a parallelogram. And that means that one pair of opposite sides equal and parallel. One pair of opposite sides equal and parallel. One pair of opposite sides equal and parallel. Okay, so look at this and think of this, but very carefully. So you have in 3.4 that you have the opposite sides PQ and BS, which are equal and parallel because this is equal to this, but they are parallel as well. So you have one pair of opposite sides equal and parallel, and because of that, we most certainly can conclude that the PQBS is a parallelogram. Okay, so just take note of that. Take note of that. Okay, so this is very, very important to consider. It's very, very important to consider. Right. Okay. So yeah, okay, we continue then. We continue to look at the next question in the next question. The next question is what we obviously need to have here. So what we need to most certainly have here. Right. So you need to ensure, obviously, that you understand what is happening here. And there are too many ways to prove this. And now we can always prove this in many ways. And another way to prove this is to establish that at this point the diagonals bisect each other. So you can find the diagonals and find the midpoints of the diagonals and be able to establish that the diagonals bisect each other. In particular, at this point, there are a couple of things you can most certainly mention here about this particular question, because we've done a lot of things like we've found the gradient of PQ, we've found the length of PQ, and we use the length of PQ just 10. The gradient of PQ, we realized the gradient of PQ was equal to the gradient of this one, of the SB or the SR or the RS, and now the equality of the gradient itself was something very important. Okay, but also, so we're good. We're good. So now we're able to therefore say QBSP, right? So we're able to then say that the QBSP is a parallelogram. It is a parallelogram simply because we're able to see that the BS itself, right, it's 10 units, but the QS, so we have a pair of opposite sides equal and parallel. This is enough. Right. Next question. Right, in the diagram below, the circle centered at M, this is circle centered at M, passes through C with coordinates -1 and 2, and cuts the y-axis at E. The diameter CMD is drawn, and ACB is a tangent to the circle. Okay, so we have that ACB is a tangent to the circle. Determine the equation of the circle in that form. How do we find the equation of the circle in the required form? We continue to take this into account. Right, to find the equation of a circle in this form, we need to realize that we need to find the length of the radius, and the length of the radius is the distance from the center of the circle to the circumference of the circle. At this point, we're going to find the radius. So we're looking at 4.1.1, and we want to determine the radius of this circle. So the radius of this circle is can be found by using the length formula, which is x2 minus x1 squared, and we have y2 minus y1 squared. So that now we have the radius. The radius. Right, so obviously now dealing with the x1, y1, x2, y2. What is x2? Is -1, x1 is that squared. Y2 is 2, y1 is a 4 squared. So we have -1 minus 2, which is a -3. You square, you get a 9. 2 minus 4 is actually exactly a -2. You square that, you get a 4, and this becomes the square root of 13. Square root of 13. Now, to find the equation of the circle, then we continue to then say you have x minus a squared plus y minus b squared. The equation of the circle must be in this form. We note, therefore, that this circle itself has the center 2 and 4, so that here you have this one is a and that is b, so it is x minus 2, and then the y minus 4, you square these, it is the square root of 13 squared, the square of the radius, and this x minus 2, you square that, and we have y minus 4. You square these, and if you have the square root of 13, it becomes exactly that. So that is the equation of the circle. In 4.1.1, because they said determine the equation of the circle in that form. So it is exactly x minus 2 squared plus y minus 4 squared equals 13. And that is the answer to the question 4.1.1. Right, in 4.1.2, want to write down the coordinates of the point D. D. This one, D. So 4.1.2. Right, to find the coordinates of the point D, there are a couple of things that remain very, very important. Yay! Right, to find the coordinates of the point D, you need to recall that this is the center of the circle, and each of these lines like MC and MD are radii of the circle. And if the radii of the circle, radii of a given circle are equal to each other, and if they are, we're able to realize, therefore, we can find the coordinates of the point D. And now at D, right, at the point D, so we can use the midpoint formula. And if we use the midpoint formula to find the midpoint, what does the midpoint formula say? Right, so the midpoint formula will therefore say x1 plus x2 out of 2 y1 plus y2 out of 2 equals the coordinates of the midpoint, xm, y subscript m. Right, so we have this. Now at this point here, you can call these ones xd and yd. These ones are xm and ym. And these ones here, you can call them anything xc, yc. You can call them like that. Okay. In each case, with those labels, then we have the endpoints. So now you need to consider the endpoints. So there's going to be an x1, which would be this one here. And then you can call this one an x1, y1, and you can call this x2, y2. So that your x1, for instance, is a -1, and x2 itself is xd. y1 is a 2, y2 is a yd out of 2, xm is this. We have this, which is 2 plus yd out of 2, which equals 4. -1 plus xd, which equals 4, which means that xd is 5. 2 plus yd is 8, and this means yd is 6. Okay, so you got the xd and yd, and this means, therefore, that the coordinates of the point D are given as follows. So the coordinates of the point D are the x is 5 and the y is 6. The x is 5 here and the y is 6. So those are the coordinates of the point D. So D has the coordinates exactly 5 and 6. Okay, why are we giving these coordinates? Look, we are dealing with the midpoint. Midpoint can be applied in many ways. We are looking at the application case of the notion of a midpoint used in a circle. Midpoint used in a circle. And we're able to see that the center of a circle is the midpoint of the diameter of the given circle. So we have that, but there are too many ways of us to do this question, but this is just one easier question, but yeah, much easier there. Let's get the next question. What's determine the equation of AB in the required form? What determine the equation of AB in the required form? How do you find the equation of AB in the required form? The equation of AB in the required form. To find the equation of AB, we need to think, but very carefully. And now, there are a couple of things, obviously, that remain very important. We must first find the gradient of the line to find its equation. So we'll first find the gradient of the line MC. So the gradient of MC is change in y, change in x. Okay, MC is this, which means you're moving from M to C, x1, y1, and x2, y2. Okay, we're looking at MC. MC describes the direction of movement in terms of vectors. So we are moving from M to C, so that at M we have the initial point, and C is our terminal point. And then this is our y2 minus our y1 over x2 minus x1. Okay, what is our y2? It's a 2. Y1 is a 4. X2 it's a -1. X1 is 2. What is 2 minus 4? 2 minus 4 is a -2 over -3. And what is this? It's 2 over 3. Okay, take note of that. And upon a careful examination of this, we have the gradient of the line MC, but MC is perpendicular to the tangent to the circle, so that the gradient of MC multiplied by the gradient of AB is -1. And this is caused by the fact that, and we can attribute that and justify that with the reason, and it is due to the fact that we have that the tangent to the circle is perpendicular to a radius. Tangent to a circle is perpendicular to a radius at the point of contact. And what is the gradient of MC? The gradient of MC becomes exactly 2 out of 3 multiplied by the gradient of AB, and that is -1. Okay. And now if you continue to simplify these, that means the gradient of AB is the same as, you cross multiply here and it becomes 3 goes there out of 2. And that tells us the gradient of the line AB is a negative gradient. In other words, it's running down slope and it is -3/2. But this line AB, whose equation you need to find, because this question says determine the equation of AB in that form, AB passes through. Okay, you can just use the word through. Right, so it passes through C with coordinates -1 and 2. So that in the end, then you have x1, y1. So that we have y minus y1 equals m into x minus x1. Through the point C is the line AB. The line AB runs through the point C, in which case you take your y1, which is a 2. The gradient of the AB line is -3/2, which is x minus, our x1 becomes a -1. And we're able to therefore get to the simplification of this. Okay, so you have y equals -3/2x, and this is plus, so that you have -3/2 plus 2. The final answer therefore can be written here so that you have y equals -3/2x, and this is exactly 1/2. Okay. We have the following. So we continue right now to solve more problems as follows. So we found the equation of the line there. See, obviously this question was asking us to find the equation of the line AB. So the equation of the line AB here is this one here, which is -3/2x plus 1/2. Right, and we've answered question 4.1.3 as that one. Take a look at it and make sure that you understand the solution to the problem. We have done a couple of things, but what have we done? And so we need to just perhaps give a brief summary. The examiner asked us in 4.9.3 to determine the equation of AB in the form y equals mx plus c. And to find the equation of AB, what do? We continue to exactly find the gradient of AB to find its equation, but the equation that the AB does not have clearly defined points, in which case, therefore, there's only one point, for instance, so we don't have coordinates of 2 points or more. So we find first the gradient of the line MC by using the gradient formula. And after we found the gradient of MC, we're able to use the gradient of MC and say the gradient of MC times the gradient of AB is -1 because tangent is perpendicular to radius. The gradient of MC, therefore, is 2/3 times the gradient of AB, which is -1, meaning the gradient of AB is -3/2. Through the point C is the line AB, so that in the end, then we have y minus y1 equals m, which is the gradient of the line AB, which is -3/2. And we simplify everything as done here. Okay, so yeah, just take note of these calculation process, but to make sure that you understand everything. Next, We look at the next question. So the next thing is to determine the coordinates of the point E, and E itself can be seen as the y-intercept of the circle. And so how do we find the y-intercept of the circle? We're going to proceed to use the equation of the circle that we got. Okay, we proceed as follows. Right, we're going to now, we're interested in finding the coordinates of E, and E itself sits there. So now at E, right, at E, we have what we call the y-intercept of the circle. With the y-intercept, how do you get the y-intercept? You let x be 0. So this one, you already know the equation of the circle from the previous question. The center is there. So with x minus 2 all squared, y minus 4 all squared equals exactly what we got. And we remember very well what we got the equation of the circle to be. It was equal to 13 here. So we want to find the x-intercept, so we let x be 0. So we have 0 minus 2. You square these, and then we have y minus 4. You square that, which equals 13, like so. And then what do we do here? What do we do here? We proceed as follows. To solve even lots of questions, we proceed to tackle this question in many ways. So yeah, okay, we simplify this, and then now this is 0 minus 2, and 0 minus 2 to minus 2, you square that, it becomes a 4, which becomes a 4. You have a y minus 4 squared, which equals 13, which is y minus 4 squared, which equals 13 minus 4, which gives us a 9. And you have y minus 4, you square these here, which becomes a plus or minus the square root of 9, which means y minus 4 is plus or minus 3. Okay. Which means, therefore, at this point, you have y minus 4 equals 3, which means y equals 7 if you bring the minus 4 to the other side. So you're taking the plus 3 here, or you take y minus 4 equals minus 3, and you transpose the negative 4, making it a plus 4, and 4 minus 3 gives us a 1. So now it means, therefore, this circle here is going to cut the y-axis at 2 possible values of y. So you need to order them correctly. This is the smallest one and the biggest one. Right, so now I want to find the coordinates of E. So the coordinates of E are as follows. So x is 0 and y is 7. Right, so those are the coordinates of the point E. There. So you take note of these and make sure that you understand everything in 4.1.4. The coordinates are 0 and 7. So now, how did we even go about doing that? We need to recall that we had to identify, because if they say, fine, calculate the coordinates of E, the students think sometimes, but what is the formula for finding coordinates? I mean, what is the formula for finding coordinates? And therefore, sometimes they become very despondent and they think, oh, this is very hard, but it's not. It's not hard. Because now to find the coordinates of the point, you need to identify the point, recognize the point, and be able to tell what kind of point it is. It is, in this case, the y-intercept. And therefore, at E, we're dealing with the y-intercept, and let x be 0. And we use the equation that is associated with that. So in this case, it is the equation of the circle, and x is 0, and we're able to get y. And therefore, we get everything that we need there. Okay, we continue now to solve the next problem. Continue to solve the next problem. Right, so we look at 4.1.5. Show that EM is parallel to AB. Show that EM Here is E and here is M. Show that EM is parallel to AB. Okay, now to show that these are parallel to each other, and a couple of things that are very important, we've already got the equation of the line AB, and so we just need to find the gradient of EM. We already know the coordinates of E are 0 together with 7, and the coordinates of M are 2 and 4. The examiner is describing these as EM, meaning you're moving from E to M, which is x1, y1, and then it's x2, y2. The gradient of EM, which is change in y, change in x. Okay, so y2 is this, y1 is 7, x2 is 2, x1 is 0. 4 minus 7 is minus 3 out of 2. This gives us exactly the equation of what? This gives us exactly the equation of EM. And therefore, what is the next step here? Right, so recall that now we need the equation of the, we need to also say, but the gradient of AB is minus 3 over 2. Okay, because it was proved in 4.1.3. Right, so and we're able to therefore see therefore the grade of EM is minus 3 over 2 and that of A over B is minus 3 over 2, and therefore the conclusion is that the gradient of EM is equal to the gradient of AB, which is minus 3 over 2. Like this. Like that. So we're happy. So this is it. But what do we do with this gradient? What do we do with this gradient? Now, we have been able to conclude that the gradient of EM equals the gradient of AB, and we're able to then say hence AB itself, or rather EM, is parallel to AB. Why are they parallel? They are parallel. EM and AB are parallel to each other. Why are they parallel to each other? They are certainly parallel to each other because of the gradient of EM is equal to the gradient of AB. Like this. Just like that. Just that way. So we have that the gradient of EM is equal to the gradient of AB, which is actually equal to minus 3 over 2 there. Right, so the couple of things, therefore, that remain very, very key to the way we reason, and let us continue to solve even lots of problems. Right, so we continue to analyze the rest of these questions here. Right, having solved the 4.1.5, we continue to look at the next one. And the next one is 4.2. Determine whether or not the circles having equations that and that will intersect. Show all calculations. Determine whether or not the circles having equations that and that will intersect. So now, to show that two circles will intersect, we proceed as follows. Show that the circles will intersect, we proceed as follows. Right, so now these two circles themselves have centers. So the circles. Right. Can write the circles here. The circles have centers. Okay, so the circles have centers, this one. And obviously you have, these are not exactly, this is not exactly this circle. So, but they have centers. For instance, let's call them P. So like this one is going to have the center -2 and 4. So this one is plus, you make it minus, and then the minus one is taken as it is. And there's Q, this one, the center, because there's a -5 and a 1, which is going to be 5 together with -1. So these are the two circles, and these two circles have those centers. Now, what then do we do with this? So we're going to find the length, QP. Right, we can find the length QP. And if you find then the length QP, or QP squared, let us find QP, the length, the distance between the two centers. So to find the distance between the two centers, we're going to proceed to use the distance formula. X2 minus X1, Y2 minus Y1. What is X2? X1, Y1, X2, Y2. What is X2? It is 5 minus X1, which is +2. You square these. Y2 is a -1, Y1 is a 4. And then 5 plus 2 is a 7. If you square it, you get a 49. -1 minus 4 is a -5. You square it. If you square -5, you get a 25. Okay, now let us look at 49 plus 25. What does it give us? This gives us exactly 74. Which is 8,60 units. 8,60 units. Rm plus Rp. Let us now look at the radius of these circles here. Because we need to determine whether or not the circles have equations, this and that will intersect. Determine if these circles will intersect. So now, if we determine this, let's call these RP, RQ. RP, RQ. Right, it's okay like that. So you have RP and RQ. What is RP? Okay, now, if we call this one P and we call this one Q, this circle has center P and this one is center Q, like we have shown here with the -2, 4. RP is a 5. RQ, this one is a 3. What is 5 plus 3? 8. So we have taken the radius of the circle with center P and the center of the radius of the circle with center Q, and we added them up, we're getting 8. Okay, so thus RP RQ is 8, but 8 is smaller than QP. Okay, 8 is smaller than QP, and from that observation, we're able to make the determination that therefore the two circles do not intersect. The two circles do not intersect. Right, two circles do not intersect. Therefore, the two circles do not intersect. The fact that the sum of the radii of these circles themselves, when added, the sum is less than the distance between the centers. So the distance between the centers is much bigger. So what you're having is, here is one circle here, and here is another circle. Maybe this one is P, these things are not to scale, and it's Q there. And if you draw like this and you find the distance between the centers, you can see that the distance between the centers is so big, but so big so that these circles here are very far from each other. And when you add, you take this one RP, the radius, and RQ, you add this radius plus other radius, it's very small. And the circles are far from each other. And this actually is a symbol of the fact that these two circles will not intersect and will be like this, like as shown the diagram there. Okay, yeah, just to take note of this, but it's indicated that this diagram drawn here is not to scale, it's not on the Cartesian plane, so this is not accurate. Okay, but the two circles do not intersect, and that is the point we're putting across. The next question. Next question. Right, in the next question, we're here to spend lots of time on these things, and right, there are a lot of things that we're gonna do and make sure that we're good enough, but let us look at this question. In the diagram below, a circle with center O passes through A, B, and C. Right, so in the diagram below, we have a circle that is center O, and it passes through A, B, and C. BC equals AC equals 15 units, and you can see the 15 here, and you can see the 15 there. Right, now BO and OC are joined. Now there is BO and OC, and they are joined, and these are radii, but OB itself is 10 units, and BOC is the size X. Okay, what do we do now? We continue to solve this question in detail. We continue to solve this particular question in detail as follows. And what do we need to do here? Right, so we need to do a couple of things here, and we need to perform a couple of calculations, etc., etc. And yeah, right. Let us do this question. We need to calculate the size of x, and x is this. All right, now to find the size of this x, what do we do? In triangle. In triangle BOC. Right, so now we are dealing with triangle BOC, and you want to find the size of the angle x. We already know this one is 10, and this is 10. These are radii. So we're going to use something called the cosine rule. Okay, it's like Pythagoras theorem, but it has a correction term, and we're going to see that. So if we are dealing with this triangle here, we're dealing with that triangle there. So now we're going to say we want to find the BC squared. So BC squared is equal to BO squared plus CO squared minus 2. BO, CO, cosine X. What is BC? 15. Because BO when BO is 10 squared. CO is also 10 squared minus 2. BO is 10. CO is 10 cosine X. So that then in the end, what we're able to get here is the following. This means you have 2 times 10 times 10 is 100, and 100 times 2 is 200, and you bring it across the equal sign, and this gives us 200 cosine X, which is minus 25. And then this means that cosine X equals minus 0,125. And then now we're going to use a calculator to get the result here. And now if you do this carefully, using reference angles, because the cosine is negative, and we know from the cast diagram that the cosine is actually negative in a couple of quadrants, in this quadrant and that, and obviously this angle here, we can see that it is an obtuse angle, that is an angle that is more than 90 degrees but less than 180 degrees. So we have the following. Right. So we continue. We continue. Right. So now I would like us to possibly give the reference angle here. Let us look at what we call the reference angle. So the reference angle will be arc cosine 0,125. So now what then do we have here? Right, now if you have these, let us check this very carefully. Right, so this is 82, 82,82 degrees. Okay, so this is a reference angle and it's 82,82 degrees, but now we have taken the positive of this particular number on the right-hand side of the equation and want to get now the value of x. So the numerical value of x, therefore, because the cosine is negative in the second quadrant, to get the second quadrant is 180 minus 82,82 degrees, which means x is equal to 82 minus 82,82, which is 97,18 degrees. So that now we're able to get x. And x is 97,18 degrees. So this is the size of the angle x. The size of the angle x. Right, so, okay, this question uses something, and this, we're going to spend a bit more time on it. It's called the cosine. It's called the cosine rule. I know that you do not have much experience, I guess, on this one yet, but yeah, we're yet to spend a lot of time on the cosine rule, so stay very, very ready to understand this. Right, so in the next question now, we want to determine the size of ACB. The size of the angle ACB. How do you find the size of the angle ACB? We proceed as follows. So if we know that this angle here, the angle X is actually equal to 97,18 degrees. So we want to find the size of the angle ACB, this angle. How do we find it? Obviously, there are a couple of things that you need to take into account there. And one of the things that we need to take into account is because you already know a lot of things. What then do we know here? There's an angle at center is equal to 2 times the angle at circumference. And so now let us use that part. So we're going to start by therefore saying the angle BAC is equal to exactly that. So we start by then saying the angle, in other words, you can start clearly by saying the angle at center is twice angle at circumference. So you can start by saying 97, or we can, yeah, let's just write a bit more detailed here to avoid unnecessary confusion. So we can start by saying the angle BOC from geometry, which is the angle at center, is 2 times the angle at circumference, which is twice angle BAC. Why? Because we have the angle at center equals to 2 times angle at circumference. Angle at center equals 2 times angle at circumference. The angle BOC is 97.18 degrees. 97.18 degrees, and this is 2 times BAC. Okay, and therefore BAC, you divide 97.18 degrees by 2, getting the quotient 48.59 degrees. 48.59 degrees. The angle ABC. Right, so we're able to see that this is BAC and it is 48.59 degrees. 48.59 degrees. So then we have ABC. Right, so that the angle ABC now, because this is equal to this triangle is therefore called isosceles. So that now the angle ABC is equal to the angle BAC, which is equal to, so this angle is equal to this angle, and this is also 48.59 degrees, which is exactly 48.59 degrees. Why is this the case? These are angles opposite equal sides. Angles opposite equal sides. Equal sides. Angles opposite equal sides. Okay, so if you have the angles opposite equal sides, because these sides are equal, therefore these angles themselves are equal. We call them base angles of the isosceles triangle are equal. Okay. If you have already 2 angles in the triangle, the third angle is obtained by using the sum of the angles in the triangle. And therefore, we conclude, therefore, we can put it here. We conclude, therefore, that what you have is ACB is equal to what? The angle ACB is 180 degrees minus this and that. So it's minus 48.59 minus 48.59 degrees. And the reason for this 180 minus is the sum of angles of triangle. The sum of angles of triangle. The sum of angles of triangle. And therefore you say that ACB is equal to 180 degrees minus that. And this is exactly what? It appears that it is exactly 82.82 degrees there. Okay, which is what we have as the size of the angle ACB. ACB. Okay, so yeah, just look at that one and make sure you understand that. Right, so That is something that becomes very, very important. If you have 180 degrees minus 48.59 minus 48.59, the result is 82.82 degrees. Okay, so that becomes the answer there. So yeah, just to take note of that as you move forward. Right. So we continue. We continue. In continuing, we solve the next problem. We've already found the size of the angle ACB. The size of the angle ACB is 82.82 degrees. And I want to find right now the area of the triangle ABC. Area of the triangle ABC. How do you find the area of the triangle ABC? You already know all the angles there, so the area is very, very straightforward. Let's continue to find the area. This one is 82.82 degrees, and this one is exactly right. See this one? Okay, this one you already know is 48.59, 48.59, and we label that. This is 48.59 degrees, and this is also 48.59 degrees, and we want to find the size, the area of the triangle. So in 6.2.3, then you're going to say area of triangle ABC is exactly area of the triangle ABC. So at this point, because this is B equals B like this, A equals A, and C equals C, so that you have half AB, the sine of 82.82 degrees. So that you have the area of triangle ABC. The A is 15, the B is also 15, the sine of 82.82 degrees, which means the area of triangle ABC equals what? Okay, let's check this one. So at this point, you're going to use a calculator to find the area. So the area here is exactly using a calculator. We can use our calculator to do this. Let's just launch our calculator here. And launching our calculator, we're able to see that if you have, for example, this one is exactly 1/2, right? And then we multiply these by 15. Multiply as well by 15. So 1/2, 15 by 15. By the trigonometric sine of 82.82. And I'm going to give you exercises to practice. Right. What we are seeing clearly is that it is exactly this. So it is 111.62. So this is exactly one. Right. You can write that one down. So it is exactly 111.62 square centimeters. Right, square centimeters. Just square units. Okay, you can put square units. So you can write like this. So you can write units squared, because they said here these are 1550 units, or you can then say the area of triangle ABC is that, 62 square units. Square units. Right. Square units. So we found therefore the area of the triangle ABC there. In this question, and we proceed to answer the next one. In the next question, now we're back to this basic grade 11 theorem. And in the diagram, AB is a chord of the circle. So we have that AB is a chord of the circle. This chord therefore runs from the circumference to the circumference of the circle with center O. M is the midpoint of AB. We can see that M is the midpoint of AB. MO is produced to P. Let us look at MO that is produced to P, where P is a point on the circle. We can actually be able to see P is a point on the circle. OM is X, and we can see OM is X units. AB is 20 units, so we can see that AB is 20 units. And also with PM over OM, we have PM, all right, PM over OM, which is 5 out of 2. Right, so now what then do we do? What then do we do? Right, so we need to therefore continue to write down the length of MB. We need to write down the length of MB. And to write down the length of MB is something very, very easy, because AB is 20 units and AB is 20 units. This one is 10, 10, because these bits are equal to each other. And now we also have this ratio of PM to OM. So if you have PM to OM is 5 out of 2, we will obviously have a beautiful way to handle that part. Okay, here's the first question. 7.1 that we are answering. Write down the length of MB. Right, so now let's write down the length of MB. So the examiner did not want any reason here, so we're able to see that MB equals 10. Right, so MB equals 10 units. MB equals 10 units because AB is 20, so MB is 10. Right, give a reason why OM is perpendicular to AB. OM is perpendicular to AB. Why is that the case? So we're going to state that one. Why is OM perpendicular to AB? So we have that line from center. Line from center to midpoint. Line from center to midpoint of chord. Line from center to midpoint of chord is perpendicular. Is perpendicular to chord. Line from center to midpoint of chord is perpendicular to chord. So line from center to midpoint of chord is perpendicular to chord. That is the theorem. So there's a line from center to the midpoint, because this M is the midpoint. How do you say it's the midpoint? Because this bit equals that bit there. So line from center to midpoint of chord is perpendicular to chord, so that this angle here is 90 degrees and that one is also 90 degrees. Now in 7.3, you need to show that this is the case. Let's look at question 7.3. Right, there are a couple of things that obviously we need to take into account. But we already know that this one is 10, this is 10, because the whole of A, B is 20, 10 plus 10 is 20. And we already have that MP over OM. MP over OM. Right, so MP over OM, the question is, what is that one? Right, so we already know, because we want to find OP, but we know that MP over OM equals 5 out of 2. What is MP? MP is X plus OP divided by OM, which is X. Right, so can do this, but you can write it a little bit more clearly, a little bit. We can add a bit more step. MP the same as OM plus OP over OM equals 5 out of 2. What is OM? It's X plus OP over OM, which is X, which is 5 out of 2. Cross multiply here, getting 2X. 2OP is 5X. Twice OP is 5X minus 2X, which is 3X. OP is 3X out of 2. So that now we have shown this here. We have shown exactly that. So now, obviously, because the examiner gave us this here, where to show this. So we know that the MP, obviously we can call it MP, but we can also just use the notation by the examiner. The examiner used the notation PM, so we can stick to that. And say we're moving from P to M, in which case it's the same as OM and OP, okay? And with that, but obviously our OM is X, the examiner gave to us, but also OM is also X in the denominator. You cross multiply everything, getting 2X plus 2OP equals 5X, and you have 2OP, which is 5X minus 2X, which is 3X. Divided by 2, you have OP equals 3X over 2. Okay, so we have shown that OP is 3X over 2 units. The last thing is to calculate the value of X. Let us find the value of X, because you already know that OP is 3X over 2. To calculate the value of X, you know that OP is 3X over 2, and this is 10. Right, so if this is the case, what then do we want to find the value of X? So how do we find the value of X? Okay, because we know that OP is 3X over 2, this one is also 3X over 2, because this is a radius, and the radius is a line segment from the center of the circle to the circumference of the circle. It's a radius, so this is a radius, and also that is a radius. So we want to find, therefore, in 7.4, the value of X. So we can tell the examiner that we're going to work in the triangle MOB. So in triangle MOB. Right. So in triangle MOB, we know this angle is already 90 degrees, so we can use Pythagoras theorem, and then we can be able to see that, Mr. Examiner, OB squared. OB squared is OM squared plus MB squared. So OB squared is 3X over 2 squared, and OM is X squared. OM is X squared. MB is 10 squared. So now if you square the 3, you get a 9 over 4X squared equals X squared plus 10 squared. You multiply through by 4 because there's a 4 in the denominator of this term. Okay, if you multiply through by 4, we have 9x squared. Multiply through by 4, getting a 4x squared. Multiplying through by 4, here 10 squared is 100 times 4 is 400. Okay, what is 9x squared now? 9x squared minus 4x squared will give us a 5x squared equals 400. Divide through by 4 by 5, excuse, so that we have exactly x squared. We have 400 over 5. What is 400 over 5? It is x squared equals 80. And therefore, if x squared equals 80, what then do we do? You take the square root of x squared equals the square root of 80. Right, so what is this square root of 80? The square root of 80 can be simplified to 4 the square root of 5, because 80 is 16 times 5. 80, this is the same as the square root of 16 by 5. The square root of 16 is exactly 4 there, square root of 5. So that is what we have, and therefore our x is we're able to make the following conclusion. And we're able to see, therefore, from this, that our x is approximately 8,94. 8,94 units. 8,94 units. 8,94 units. So we continue. We continue. We continue to analyze these things and make sure that we're good. So we have the value of x, which is 8,94 units. So the value of x is 8,94 units. As we got the value of x is 8,94 units, we have the following. Right, so now in the diagram below, the circle, in diagram below, yes, the circle with center O, here is O, passes through A, B, C, and D. AB is parallel to DC. Right, you can see AB is parallel to DC, and also angle BOC is 110 degrees there. BOC is 110 degrees. The chords AC and BD intersect at E. Right, we can see E there, where the chords AC, right, so we have AC and also BD. BD intersected E. Right, so you have the rest of the other lines have been joined. For example, you have that EO. EO is joined and also BO. BO is joined and also CO. CO is joined and also BC. So you have that BC. BC is also joined. Calculate the size of the following angles, giving reasons for your answer. The size of the angle D. Calculate the size of the angle D. Right, so to find the size of the angle D, we use our theorem there. What do you think the size of the angle D is there, Tando? What do you think? We're looking at 8.1.1 and want to find the size of the angle D. What do you think? Obviously, we need to remember what we say here. There's an angle at center is twice angle at circumference. So if this is A or B, C, we always say that A or B, this is equal to twice angle C. So that now the angle at center is twice angle at circumference. We know that this is the diagram below of a circle with center O. So O is the center of the circle. To find the size of the angle D, we're going to therefore say the angle BOC equals exactly twice D. And that is what we can state and say the angle BOC is 2 times BDC. The angle BOC is 2 times BDC, angle at center, equals 2 times angle at circumference. So the angle BOC is 2 times BDC, or you can even go on to just be more elaborate here and be more specific and say the angle BOC, it's 2 times angle D. In which case, therefore, you have BOC, and BOC is 110 degrees, and this is 2 times the angle D per substitution. There, obviously, I mean, here we can give the reason why the BOC is replaced by 110 degrees. You can tell the examiner that the angle BOC is 110 degrees because it was just given that way. At this point, you divide by 2, both left and right, getting 110 degrees. You divide it by 2, and that is 55 degrees. And we're able to see that the angle D here is actually equal to 55 degrees there. Right, the next thing is we're interested in finding the size of the angle A. What is the size of this angle there? So what is the answer to the size of the angle there? So think about it. This one is 55 degrees. What is the size of the angle A? What is the size of the angle A? What is the size of the angle A? Right, so the size of the angle A is very, very straightforward. Let us look at these, but also think very, very carefully. So now, there are a couple of things that remain very, very important. To find the size of the angle A is the theorem we started grade 11. We can do this. And also, this theorem can also be drawn like this. Can also be drawn differently. Like this. So you can move this one here. If you imagine this like being a rubber band, a string that you can just move like this, so this diagram is like this. So it's exactly that. So we have this here, that is this way, and we have this there, that is like this. So the angle at center is twice angle at circumference. So we're able to see, therefore, that angle O1 is 2 times A. The angle O1 is 2 times angle A. And the reason for that is that angle at center is 2 times angle at circumference. Angle at center is 2 times angle at circumference. So 110 degrees is twice A. And therefore, it means, therefore, that the angle A itself is equal to 55 degrees as well. The angle A is 55 degrees. And here we are replacing the angle O1 by 110. So tell the examiner, that Miss Examiner, angle O1 is 110 degrees. Why? Because it was given that way. This one is 55 degrees. This is also 55 degrees. Want angle E2. Want to find the size of the angle E2. How to find the size of the angle E2? Angle E2, what is the size of the angle E2? Right, E2 is an angle that sits exactly there in that part of the diagram, and therefore, how do we get the size of the angle E2? So we proceed to try that one. The next question. Right, so 55 degrees. 55 degrees. This one here we've already seen that D is 55 degrees, but also A is 55 degrees. We need O2, but this one, these are alternate angles if this is parallel to that, so that the whole of this angle is also 55 degrees. We go back to grade 10, and when you get to grade 10, we remember something here, that at grade 10, we're taught that if there is a triangle like this, A, B, C, 1, 2, A plus B, angle at center, what is it? The exterior angle of triangle. Exterior angle of triangle. So we say the exterior angle of triangle is the sum of the interior opposite angles, in which case it's evident there, so that we're able to see that the angle E2 is equal to 55 plus 55 degrees. Right, so we're able to see, therefore, that the angle E2, so, but first things first, we can just give a reason why this, the angle, let me see. You can just describe a reason why this actually it's the case in 8.1.3, because we want to find the E2. So we can say B1 equals D. B1 equals D itself. Right. And then now we find that one, and then E2 is actually the same as B1 and that. Right, so we're able to see therefore that the angle E2, so yeah, the angle E2 now can be found in just two many ways. But one way to look at that is to realize that the angle, right, by using alternate angles here, because you can see that you have been given that AB is parallel to DC, we can give the justification of the fact that the AB itself is parallel to DC as the examiner stated up there. So if that is the case, we're able to see therefore that the angle A is equal to the angle ACD. ACD and is 55 degrees. Why? These are alternate angles. Why are they alternate angles? Because AB is parallel to DC. This has produced this angle of 55 degrees there. But obviously we know that AC is a chord. Chord AC means that this is a straight line, so we can do these kinds of things we're doing. Now, from this point, we can see that the angle E2 itself is equal to the angle D plus the angle ACD. So the angle E2 is D plus ACD. How do we say that? We're able to say that because of the exterior angle of triangle from grade 10. And this allows us to say the angle E2, the D we know already is 55 degrees. It was proved above, but the ACD is also 55 degrees. And this means the angle E2 is 55 plus 55 degrees, which is 110 degrees. So this angle is 110 degrees. 110 degrees. So the next thing is to prove that BEOC is a cyclic quadrilateral. BEOC is a cyclic quadrilateral. So to prove that BEOC is a cyclic quadrilateral, we need to prove that possibly we have angles in the same sag. And this is just awesome, awesome stuff. So I want to prove that BEOC is a cyclic quadrilateral. We already know that this one is 110 degrees, but also this one is 110 degrees. This gives us our old friend called the bow tie result. So we have a bow tie here, and these are clearly angles in the same segment. Right, so if we have angles in the same segment like so, this angle equals this. In this case, this angle here equals these angles there, and these are angles in the same segment, making the quadrilateral a cyclic quad. So to prove that BEOC is a cyclic quadrilateral, we proceed as follows and say the angle E2 is equals to the angle O1, which equals 110 degrees. E2 equals O1, which is 110 degrees. Why is that the case? It has been proved. Right, it has been proved in 8.1.3. Okay, that is where we got the E2 from. So you say proved in 8.1.3. Right, in 8.1.3, we established that E2 is 110 degrees and or 110 degrees given. And this means that we can therefore say, therefore, BEOC is a cyclic quadrilateral. It's a cyclic quadrilateral. Why? Why is it a cyclic quadrilateral? The cyclic quadrilateral because the equal angles subtend. Equal angles subtended. Equal angles subtended by line. Right, so this line subtends equal angles, and therefore we're able to then say that BOC is a cyclic quad. Why? Because equal angles subtended by line. And therefore, this BEOC is a cyclic quadrilateral. Right, what an awesome question we've had. We actually were able to show that the angle D is 55 degrees there as part of the diagram, but we're able to see that the angle A is also 55 degrees there as part of the diagram. The angle E2, we saw that is 110 degrees. This is cyclic quadrilateral because it has been proven there. It was awesome having a discussion with you there, Tando. A very, very interesting discussion we've had, and we are excited to have had this discussion. Thanks a lot for joining us. I'm going to make the video available during the course of the evening, but I'm going to send the homeworks on the group. Right, so yeah, it's great discussing more mathematics.